Okay, so in the last video, we learned about the classes of machine learning. We saw how many types there are, that machine learning has three types, what those types are, and their information. Now, what we are going to do is, first of all, what is machine learning? How can we actually train a machine? How does a machine learn? How is it useful to us? Let's see that in this video. First of all, I thought of explaining this with an example. For example, let's say you have coffee. Suppose you want to learn how to make coffee. How would you learn? You have two options. One, you can learn using the traditional method. What is the traditional method? Someone tells you how to make coffee, how to boil the coffee, when to add the powder, the timings, and if it's milk, when to add the milk. That's one method. What is the second method? What is a trial and error method? You can make coffee all by yourself without anyone teaching you by trying out all kinds of experiments. So, just like there is a traditional method and then there is the trial and error method, we can learn things in both these ways. We train machines in the same way. One way is by giving the machine information and properly telling it, this is good, this is bad, and teaching it. The second way is by giving the machine a situation and allowing it to learn on its own. If a machine is able to learn on its own, we call that machine learning. So there are different types of learning. As we have seen, there is supervised and unsupervised learning. This comes under supervised learning. In supervised learning, we clearly explain everything. We tell the machine what the input and output are and how they are related. But if the machine learns on its own without such guidance, we call that unsupervised learning. Okay, so unsupervised means without any supervision, without anyone telling it what to do, the machine figures things out on its own. It tries to understand the patterns by itself. That's the idea. So, when we move forward and look at things like computer vision and classification, let's also understand supervision in detail in those contexts. So, this is the basic definition in machine learning. Next, in machine learning, we took a particular example and understood it in detail. For example, for you, let's say house price prediction, or since that's a very common problem, let's look at the marks versus rank example we discussed earlier. So, when we talk about marks versus rank, suppose a person gets certain marks. Okay, what's the range of marks? It could be from 0 to 200. When someone gets 0 marks, let's say their rank is 100. That's the rank of that person. If someone gets 10 marks, we say their rank is 15. If a person gets 100 marks, their rank is, we call that one. If you observe here, both of these are linear. That is, when this increases, the other decreases. When one decreases, the other increases. So it's clear that they are linear. Now, what formula should I use here so that x becomes y? That's what I need. This is what we call a model. We call this input. We call this output. We call this process. This is a very important and fundamental concept in machine learning. Instead of simply calling it input, we can also precisely call it features. Instead of calling it output, we typically call it a label. Instead of calling it process, we generally call it a model. So you need to remember these technical terms. For example, when you give 0, it becomes 100. When you give 10, it becomes 50. When you give 100, it becomes 1. Why is this? What is the use of this? Suppose in the future we want to predict something. Let's say a person gets 50 marks. Then what are the chances of that person getting a certain rank? Predicting what rank that particular person is likely to get is called prediction. This is what we mean by future prediction. Right now, there is no one with 50 marks in our class, but if tomorrow morning someone gets 50 marks, what rank should I assign to that person? This comes under predictive analytics. Now, why is this used? For example, the LLMs we are looking at, like ChatGPT and others, all fall under prediction as well. For example, Ben ilode eri iwole is I am let's say you said I am good, okay? How are Dash? Okay, so now imagine you're chatting with a chatbot like this. Suppose you said, I am good, how are Dash? Then at this dash, what does the machine predict? It might predict good. It might predict you. Suppose there are multiple options in the product discussion. What is the possibility to select among them? How are you is obviously clear to us as humans. Here, this is the best option. This is what production is, meaning for many words, we have thousands or even millions of word options, right? Out of those millions of words, it selects the best words and places them here. What our chatbot does is it takes the question we give as context and it keeps generating the next word one after another. So now, let's say ChatGPT gives an output like this. Suppose after you, we need to fill in the blank. For example, after you, what should be written after I am good, how are you? The next words could be oh, you are. When we say you are, now a dash comes here. Here I'm explaining the production of ChatGPT. So after I am good, how are you? We usually say hope you are good, right? If we want the phrase hope you're good to appear here again, what happened is that previously we gave a higher probability to the word you. Next, now we gave a higher probability to the word good. So if the machine can predict which word should be given what probability and which word comes next, that's all we need. That's exactly what language models like LLMs do. It's the same here as well. Look, now the model I trained with 0, when I give it 10, when I give it 5,000, and when I give it 1. Now, when testing, I gave 50. At that point, what are the chances that are equally likely? For example, let's say I have multiple options here. I can put 0, 50, 20, or 100. I gave all these options. When you ask, what is the best option among these? Look, for 0 and 100, the probability drops equally. When it comes to 10, it drops by 50% again. Now, when I reach 50, what should happen? It should drop even further. It should be less than 50. So, what is my option then? The best option is 20. So, what does the machine do? It selects the best probability among all these options. This one has the best probability. So, how much does it have? Let's say this one has a 50% probability, this one has 10%, this one has 5%. In this way, it assigns a probability percentage to each option. So, ultimately, the concept of machine learning is to predict the next value, especially if you are talking about LLMs. Now, even in the example I just mentioned, what do? We try to predict future values. When you say 50, what is the next value that comes? If you are able to predict that, you have built the best model. But this is not all that easy. There are many more complications involved. We have autoencoders, variational encoders, transformers. Okay, we need to learn about neural networks, and after that, all of this will become clear. But since I have to give you a definition of machine learning, I'm explaining it to you with an example. In the next video, let's learn some basic mathematics so that we can understand that mathematical concept, and then we'll take an example in machine learning, and after that, we'll learn about the algorithm.